Arithmetic sequences are a type of sequence that have a common difference. And like the name says, a common difference is a common number or consistent number that is being added or subtracted to the previous term. So if you look at the top three sequences, we can find the common difference. So for 4, 7, 10, 13, 16, I can see to go from number to number, I am consistently adding 3. 4 plus 3 is 7. 7 plus 3 is 10. Plus 3 is 13. Plus 3 is 16, and so on. So this is clearly arithmetic because of that common difference. If we go to the next one, 42, 37, 32, etc., we can see that the numbers are going down, which means our common difference is negative because we're subtracting or we're adding a negative number. So from 42 to 37, I am subtracting 5 or adding negative 5. And finally, for the third sequence, we're starting negative, but our numbers are growing, and they are all increasing by 8. So all three of these are arithmetic sequences because of that common difference. Now, if something is an arithmetic sequence, there is an explicit formula that we can use and that we can determine. And this is the explicit formula. Tn, which is any general or any number in the sequence, is equal to a1, which is the first term, plus d, where d is the common difference, times n minus 1. And n is the position number of that specific term. So for example, the 10th term, n equals 10. The 20th term, n equals 20. Now I'm just going to show a little example here of where this formula is coming from. So if I just look at a simple sequence, 3, 5, 7, 9, 11, my first term is 3, and my common difference is 2. So I'm adding 2 each time. And I'm just going to write this for the visual. And I'm also going to write the position number. So 3 is the first term, 5 is the second term, 7 is the third, fourth, and fifth. Now, we're starting at 3, and we're adding 2 a number of times. So when I get to my second term, which is 5, I have added on 2 one time. When I get to my third term, which is 7, I have added on 2 two times. When I get to my fourth term, I have added on 2 3 times. When I get to my fifth term, I have added on 2 4 times. And I can just see this by looking at the number of 2's I have. So to get to 11, here's the first addition, second, third, and fourth to get to 11. So each time I'm adding the common difference of 2, one less than the position number I'm in. So for the fifth number, I've added on 2 4 times. For the 8th number, I would be adding on 2 7 times. For the 100th number, I would have added on 2 99 times. So that's where our formula is coming from. I'm taking my first number, so my first number is 3, and I'm adding on the common difference of 2, n minus 1 times. So 1 less than the position number you're in. Now let's try a sequence that we're going to graph and find the explicit formula for. So this sequence here, 12, 6, 0, negative 6, negative 12, is arithmetic because it is going down by 6 consistently. So the common difference is negative 6. Now I'm just going to write the position number. 12 is the first, 6 is the second, 0 is the third, negative 6 is the fourth, and negative 12 is the fifth number. And now I'm going to graph. And before I graph, I am going to label my x and y axis. So the x-axis is the term number, and the y-axis is the number in the sequence. So now let's graph. So the first number is 12, the second number is 6, the third number 0, the fourth number negative 6, and the fifth number negative 12. And I can see that these dots are creating a linear relation. So that's very important. to note. An arithmetic sequence is linear because you have that common difference. Now, because it is linear, and we know from grade 9 that a line has a slope and a y-intercept, let's go ahead and figure out what the slope and y-intercept is. So for the slope, I know I would be doing rise over run, so I'm just going to take 2 of my points here, and I'm going to see what the rise and run is. My rise, I'm going down 6, and my run is 1. So my slope is negative 6 over 1, which is negative 6. And that's exactly what we said that the common difference was. So slope is the common difference. Now my y-intercept, if we extend this line and we go upwards, I know my y-intercept is just going to be 6 more than that first term. So my y-intercept is 18. So if I were to write my equation in y equals mx plus b, just for fun here, my equation would be negative 6x plus 18. And that's just using our grade 9 knowledge of a line. Now let's actually use the arithmetic sequence here. So we said that the first term is 12 because that's given, and the common difference is negative 6 because we're going down by 6 each time. So if we use the formula, Tn equals a1, which is 12, plus the common difference, which is negative 6, times n minus 1. Now, I don't think this is very good form, having the double signs, so I wouldn't write it like that. I would just go straight to 12 minus 6 times n minus 1. And now let's just clean this up. You don't have to. You can work with your explicit formula in this form, but I'm just going to distribute that negative 6 in, collect my like terms, and then compare it to my y equals mx plus b. So if I distribute that negative 6 in, negative 6n plus 6, and if I collect my like terms, the 12 and the 6 collect to 18. That's exactly the same as the y equals mx plus b formula we came up with. And that just, again, shows you that an arithmetic sequence is linear. So that's a very important connection to make. Arithmetic is linear, and the common difference is the same as the slope of the sequence, or of the line. Now, using that, let's go ahead and move up in the level, because in this sequence, I gave you the common difference, I gave you the first term, so there was no problem finding that explicit formula. But if we look at the next example, I'm not giving you all of that information. So we have determined the explicit formula for the arithmetic sequence, so you're told that has a common difference of 8 and T12 is 83. Now a common difference of 8 means D equals 8. And this notation of T12 equals 83 just means the 12th term is 83, okay? It also means that 12 is your n value in the formula. So let's go ahead and just put what we have in this common difference. So Tn equals a1 plus 8n minus 1. That's all I know for sure in my formula. But obviously for an arithmetic sequence, we also need the first term. Now, if you wanted to, you could work backwards from the 12th term to get to your first one, which is doable in this scenario. But if I gave you the 100th term, you don't want to sit there subtracting 8 to get to your first term however many times. That would be very annoying and very tedious. So instead, let's use this 12th term. So instead of n, I can put 12. I won't know a1, I'm going to solve for that. And instead of Tn, which represents the number in the sequence, let's put 83 because the number 83 is in the sequence. And now we're just cleaning up and isolating for a1. So 83 equals a1 plus 8 times 11. Make sure you're following your BEDMAS knowledge. Let's simplify the brackets first. Now let's do our multiplication. 8 times 11 is 88. And then to isolate for a1, we're just going to bring 88 to the other side. and it's going to turn into a negative. So 83 minus 88, negative 5 for A1. So that just means our first term is negative 5. And now that I have my first term, and I was already told the common difference, I can go ahead and write my explicit formula. Tn equals A1 plus the common difference times n minus 1. Now let's actually use this formula just for fun, and let's say I want the 24th term. If I want the 24th term, I'm just going to replace n with 24. And the way I would write that for good communication, T24 equals negative 5 plus 8 times 24 minus 1. Now if you want to just jump straight to the 23 there, that's totally fine. So 8 times 23. And now we can just clean this up a little bit. So 8 times 23 is 184. And when I add negative 5 to that, I get 179. So the 24th term is 179 in this sequence. If I wanted, I could also give you a specific term and ask you what position number is it in, but we'll save that for the next example. So in the next example, I've made it a little harder and I haven't given you anything. I didn't give you the first term and I didn't give you the common difference. Instead, I just give you the 5th term, which is 10, and the 13th term, which is 42. Now, that means we need to find the first term and the common difference. And you always want to start with the common difference. Just like in grade 9 with y equals mx plus b, you always started with the slope. So knowing that linear connection and knowing that the common difference is the slope, we can use our slope formula here to find the common difference. Because these two terms can be written as coordinates. The 5th term is 10. I can write that as 5, 10. And the 13th term is 42. So I can write that as 13, 42. And if these are just coordinates, and I know that an arithmetic sequence is linear, I can do my common difference or slope formula. So my common difference D would just be y2 minus y1 over x2 minus x1. That's our slope formula. So let's go ahead and do that. In this case, I will just label x1, y1 for my first term, x2, y2 for my second term, and now I'm just subbing into my formula. 42 minus 10 over 13 minus 5. Clean it up, and we get 32 over 8, which is 4. So our common difference is 4, and that is using our nice linear connection and using something very familiar, which is slope. And from here, I now have my common difference, and I have two terms I can use. So we're back to the previous example. Now, before I continue and find A1, there's another method you can use to find the common difference, and that is, if you're given a term, you can always sub that information into your general formula. So I'm just going to write the general formula quickly up here, just for the visual, and now I'm going to sub it in. And I'm just going to start with the 13th term, and I'll explain why in a little bit, but I know Tn is the actual number in the sequence, which is 42, and that's equal to A1. We don't know the first term, we don't know the common difference, but I know it's the 13th number, so 13 minus 1. And I'm just going to clean that up. A1 plus 13 minus 1 is 12, and instead of writing D times 12, I'm just going to write 12D because that's where we usually put the coefficient. And then for the 5th term is 10. I still don't know A1. I still don't know my common difference, but it's the 5th term, so 5 minus 1. And again, I'm going to clean it up. 5 minus 1 is 4, so I'm going to write 4D. Now, I have two equations with two unknowns. This should remind you of a linear system from grade 10. And when I had a linear system in this nice setup, one method we could use to solve is elimination. So I noticed that my A1s both have a coefficient of 1, which means if I just subtract my two lines, A1 minus A1 is 0, and that variable is gone. So 42 minus 10 is 32. The A1s are gone. 12D minus 4D is 8D. And now I can quickly divide both sides by 8, and I get the exact same common difference of 4. So regardless of what method works for you or whatever method you use, you'll get to the same common difference, and then we're back to the previous example. So if we have our common difference, we can pick either of the two terms. I'm just going to use the smaller term, so the fifth term is 10, and then I'm going to use my common difference. So right now, what we know is Tn equals A1 plus 4n minus 1, and now I'm going to sub this point in, 5 for n, and 10 for Tn as a whole. 10 equals A1 plus 4, 5 minus 1. And again, you can subtract 5 minus 1 right away to have 4 times 4. And now it's grade 9 isolation. 4 times 4 is 16. Bring the 16 over, and you'd be subtracting 16 from both sides. And 10 minus 16 is negative 6 for your first term. And once you have that, we can write our explicit formula. Tn equals negative 6 plus 4n minus 1. Now I want to do one more type of question based on this formula, and that is, what number or what position number is 98? So Tn equals 98. What is n? So let's find the position number of 98. Now, if we have this, then we can plug 98 into our formula for Tn. And once we do that quick substitution, we are just isolating for n. Now, before I can isolate for n, I do want to clean this up. So I'll distribute my 4 in. And now it's up to you if you want to collect your like terms or bring both constants to the other side right away. I'm just going to clean them up to get negative 10. And now I can add 10 to both sides to bring it over. And 98 plus 10 is 108, which is equal to 4n. And then we can divide both sides by 4, and you get 27 for n. That means the 27th number is 98. So that is your arithmetic sequence. We now know what the explicit formula is. We know how to find the explicit formula if you're just given the sequence, if you're given the common difference and a term, or if you're just given two random terms. And then there are two different ways you can use the formula, whether it's I give you the position number or I give you the actual number in the sequence and you have to find the position number.